Hey, my name is Josh, and today I'm going to be discussing some of the design considerations that went into one of my projects called the Hex Sigil Backpack Mod. What that is essentially this thing. It's a backpack with a hole in it, and it's got a really cool feature, which is that if you put a magnet next to it, then some NeoPixel lights light up. And specifically what I'm going to be going over is this piece right here and some of the design considerations that went into that. It snaps on. It has a few different really cool aspects to it. One of them is the whole light diffraction part. The other concept is how it's using magnets to hold it on the bag. I mean, there is limits, of course, but that's kind of not going to happen in real life frequently. And then another kind of interesting part to it is how all of the different pieces are held together using a friction fit mechanism. So I will be covering all of these topics today in this project. So let's take a closer look at this piece here. You can see that it's comprised of three separate individual parts. You have the white base, you have the solid clear infill, which diffracts the light, and then you have the faceplate, which holds everything together. On the back, we can see I actually have this hole kind of thing. Generally, the idea with light diffraction is you want to make sure that the plastic is as thin as possible so it doesn't absorb too much of the light. And this is what the infill piece looks like exactly, just all on its own. It has these holes here all around, which are used to ultimately hold the piece in place, and I'll cover that shortly. And then it has this hole here, which ensures that maximum light can diffract. If I were to design this piece again, I wouldn't quite design it like that. I would probably tweak it a little bit so that it has even thinner amount of thickness, which would diffract the light even better. This is another one of the pieces. It is the part that holds everything together, basically, or that everything is sandwiched with. And it has these sort of spaces, whole squares right here, which are used in conjunction with the magnets. So these squares are 0.15 millimeters bigger than a magnet. And that's just barely enough for you to be able to fit a magnet inside and press it in there pretty well. It actually is kind of hard to do. But it's strong enough that, you know, the magnetism is going to go through that entire part. And that's pretty much doing two things with the project. One, it activates the reed switch, which turns on the whole circuit. And the other thing is the other areas are strong enough to actually affix the entire part to the bag. So once you've added the magnets to all the different spots, we can start assembling the actual piece. The last part of the assembly is the actual faceplate, and this is what snaps everything together. It has these really long legs, as you can see right here, which are exactly the same size as the holes here and exactly the same size as the holes here. So that's kind of how everything snaps together. I also made one artistic design decision, which is on this faceplate. It has these little nubs on the side, and I secretly use those to align with the magnets. So I can easily find where the magnets are without trial and error, which comes important later. Once we have the magnets in place, we're ready to assemble the part. So it's pretty simple. There's only 3 steps. You have the insert, you have the magnet part. You just want to make sure that you take note of where the magnets are, and then you can put the insert, and it just sort of snaps in place. That's because the insert is a hexagon, the white piece has a hole for a hexagon, and with their powers combined, they can be sandwiched together. From there, you just match up the holes with the legs of the faceplate and push everything together, snap, 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 snap. And it doesn't even snap that hard, but that's still good enough. Now it's holding everything in place, and that's pretty much all there is to making this piece work together. The last thing to discuss is how you actually use those magnets to put the part on the bag. And so inside the bag, in a separate video, I'll be covering the entire assembly instructions for this, but I have another part here, which I've sewed on to the bag, and it has magnets inside of it. So those magnets are exactly aligned with the magnets on the faceplate, and that's it. That's how they're all held together. Magnetism is something that I didn't really think of at first. It just sort of was a natural evolution of this project, and I realized that it actually works. One funny thing I had to do on the part inside of this bag is stack a whole bunch of magnets in each of the different corners, because the little teeny magnets that I'm using in the faceplate are not actually strong enough. They need a little bit more oomph. So that's it. That's all I got for this video. Feel free to subscribe if you want to see more build videos and get a little more insight into part design. Thank you.